morning everyone. Today we are going to see operating system unit 3 session 5. In the previous session we have studied the concept critical section and its three conditions to synchronize the processes. So in today's session we are going to see how to implement the critical section with the three conditions in the operating system to synchronize between the two processes or the multiple processes. So there are various solutions to solve this critical section problem. So we'll see the algorithms one by one which are more suitable to solve this critical section problem. Many systems provide hardware support for implementing the critical section code, and it is based on idea of locking the critical sections. So there are many hardware support for implementing the critical section code. Many systems provide, and the locking system is used to solve this critical section problem. We'll see. So the first approach we are going to use, that is strict alternation approach, to solve this critical section problem and to synchronize the processes. So the strict alternation approach, or it is also called as turn variable approach, is the software mechanism implemented at user mode of operating system. It is a busy waiting solution which can be implemented only for two processes. So this solution is only for two processes. So in this approach, a turn variable is used which is actually a lock. So turn variable is used in this algorithm solution which is actually used for locking that critical section part. They share a variable called turn variable S. This turn variable will be shared among the processes as it is only for the two processes. So this turn variable will be shared among two processes. So this is the critical section format as we have seen in the previous session also. So when the processes enter into the wants to execute the critical section part, they enter into the loop, and before entering into the loop they are going to acquire the lock. They need to acquire the lock. Once the lock is acquired, they are going to disable the interrupts, means no any other interruption from other processes until it finishes the execution of critical section part. So after entering the critical section part, it is going to execute that code, and after finishing the execution of that code, it is going to again enable the interrupts so that other processes can enter into the critical section, those who are waiting outside the critical section to execute. So these disable interrupts are like locking system here. So this should be locked so that no any other interruption from the processes when already there is a processes inside the critical section. So in this algorithm we are going to see turn variable is shared and its default value is initialized to 0. So we need to understand that if turn value is equal to 0, then it means that the chance is given to first process P0 to enter into the critical section. And if turn value is equal to 1, then we should understand that the chance is given to the second process P1 to enter into the critical section. So turn value is equal to 0 means P0 is going to enter into the critical section. If turn value is equal to 1 means P1 is going to enter into the critical section. So in this solution, how this works? Locks are acquired before entering a critical section and then released upon executing the critical section code. When a process wants to enter the critical section, it checks if lock is 0. So when the process P0 wants to enter into the critical section, it checks that whether lock is 0. If the lock is 0, then we should understand that there are no any other processes in the critical section. If so, it sets it to 1 and enter critical section. Now it is going to lock it by making the turn value equal to 1. By making the turn value equal to 1, it is going to lock. After it is done, it is reset to 0. Yes, after coming out, again it is going to make that turn value is equal to 0 so that other process can enter into the critical section. So we are solving we need here mutual exclusion for accesses to the lock variable itself. So how this locking system works? So acquire the lock before using it, before entering into the critical section. Then after execution of critical section code, unlock it so that other processes can enter into the critical section. Wait is, if some other process is already there in the critical section, wait until it is unlocked. So this process we call it as two-process solution. So at default, the initial value of turn is equal to 0 now here. So first we'll see the process P0 wants to enter into the critical section, wants to execute. So it enters into the loop here. So you can see this loop. For this loop we have here semicolon. You can see here semicolon. So for the loops we don't use the semicolon, but for this loop we have used the semicolon because this is one trap, this is one trap, this is one lock where if the process tries to interrupt in between, then it is going to trap that process until that the process which is there in the critical section comes out. So that process which is trying to interrupt will be trapped in this loop because we have used here semicolon. Infinity loop is, if this condition is true, it is going to trap that process. You can also see for this loop you don't have the loop body. So if this condition is false, it will come out of the loop and enters into the critical section. So for this loop we don't have the loop body. This is just a condition. When the condition is false, it will just come out of the loop and enter into the critical section. If the condition is true, it is going to trap that process. Now let us see how this algorithm synchronizes two processes. The turn value is 0. Now the process P0 wants to enter into the critical section. So it enters into the loop. Now the turn value is not equal to 0. The condition is false because turn value is 0 and they have given here not equal to 0 means condition is false. So it is going to enter into the critical section, and after the execution of critical section, it is going to change the turn value is equal to 1. Now this is the coding of process P1. So the process P1 wants to enter into the critical section. So enters here. Now it checks whether turn is not equal to 1. So here already the turn value is 1 here. So the condition is false. So it's enter into the critical section. So P1 enters into the critical section, and after execution it is going to make turn value is equal to 0. Now let's see the interruption, the in between if the process makes. If the interruption from other process comes, what happens? So the process P0 wants to enter into the critical section. So at the beginning the turn value is 0. So it is going to check whether the turn is not equal to 0. So condition is false. So it enters into the critical section. Now P0 is there in the critical section. Now even the P1 wants to enter into the critical section. So P1 interrupts in between. Now it checks here the loop. The turn value here is now 0. So turn value is here now 0. So turn is not equal to 1. See, the turn is not equal to 1. But the condition is true here because the turn is not equal to 1. So when the condition is true, it is going to stuck the process here. It is going to stuck here because already the process P0 is there in the critical section. It is executing and still it has not changed the turn variable. So whenever the process P0 finishes the critical section and when it changes the value of turn is equal to 1, then this condition becomes false. So when this condition becomes false, immediately the process comes out and enters into the critical section. And then it is going to execute and it is going to make turn equal to 0 before leaving the critical section. Another situation is, now suppose P0 wants to enter into the critical section. So turn value at the beginning is 0. So the condition is false. It is going to enter into the critical section, and after executing the critical section, it is going to make turn is equal to 1. Now P1 is not interested to enter into the critical section. So again the P0 becomes interested to enter into the critical section. So P0 enters into the critical section. Now it checks the whether the turn value is not equal to 0. But here the latest turn value is 1. So it is going to check here whether the 1 is not equal to 0. Yes, condition is true here. And P0 gets stuck here. So what is happening here? Forcefully, strictly the chance is given to process P1. Even if the P1 is not interested to enter into the critical section, the chance is given to P1. So same, the P0 has recently completed the execution of critical section and still it wants to enter into the critical section. Then we are not giving the chance for process P0. So this is where this condition we'll call it as progress condition. We call it as progress condition. So in this algorithm we are meeting the mutual exclusion condition. That is, when one process is there in the critical section, we are not allowing the other process to enter into the critical section. Next condition is bounded waiting. Yes, when one of the processes is there in the critical section, we are making that process to wait in the loop. So until it changes the turn value, we are not allowing that process to enter into the critical section. That is a bounded waiting is also happening here, but progress condition is not happening here because forcefully, strictly, we are forcing the other process to enter into the critical section even if that process is not interested. Here P0 wants to go again in critical section, but we are not giving the chance to P0 even if P1 don't want to go into the critical section. So this solution meets the mutual exclusion condition, bounded waiting, but this solution does not meet the progress condition. So this algorithm fails here, because in this algorithm the alternate chances are given to each other. When P0 process finishes its critical section, then P1 will be given the chance. When P1 finishes its critical section, then again P0 will be given the chance. Then similarly, when P0 finishes, then again P1. So this alternate chances are given to each other. Even if they are not interested, they have to go in the critical section. And if that process does not go into the critical section, the other process keeps on waiting, and like this way the process goes in a hanging mode where this process does not synchronize. In strict alternation approach, the processes have to compulsorily enter into the critical section, alternatively whether they want it or not. This is because if one process does not want to enter the critical section, then other process will never get a chance to execute again. Then that process has to keep on waiting. So in today's session, we have seen the two process solution on this critical section that we call it as strict alternation approach, which meets only mutual exclusion condition, bounded waiting, but not progress condition. Thank you.